Hello, my dear students. Once again, I welcome you all in today's class. So, as you know, our subject name is Mechanics of Solid and subject code is 1625303. Still, we are seeing our Unit 1. So, today's topic is Euler's Theory. Once again, I will repeat it, Euler's Theory. If you will talk about the topic Euler's Theory, it is one of the most important topic from Unit 1 because if you will talk about the examination point of view, so one question will surely come from Euler's theory. Understand? In previous classes, we have seen what is column and strut. So according to that, in Euler's theory, one question will come surely. So you should focus on this topic. As you know, my name is Sudhir Kumar, a lecturer in mechanical engineering from James Buckingham College, Aurangabad, Bihar. So today we will see some content which will be related to Euler's theory. So first of all, we are going to see what are the content which we have to cover throughout our lecture. So in today's class, content of the lecture are assumption in Euler's theory. Second thing, Euler's formula for buckling load. Third things, limitation of Euler's formula. And the final fourth things, Ranki's formula for buckling load. That means throughout this lecture we are going to focus more on this particular topic. First we will see what are the assumptions in Euler's theory. The second thing we will see Euler's formula for buckling load. Already we have seen what is buckling load. So now we will see what are the Euler's formula. What the Euler's gave formula for buckling load. Then we will see limitation of Euler formula, and finally we will see Ranki's formula for buckling load. So we will start with our first content, assumption in Euler's theory. Assumption in Euler theory. See, this is very important. Actually, if you will refer 2 or 3 questions paper, most of the question paper they will ask theory also. What are the assumptions Euler's made for column? Understand? So you have to remember these points. I have clearly mentioned here 6 points, so you have to at least remember 5 points. Understand? So now we are going to see what are the assumptions in Euler's theory. It will help in solving numerical problem also or in theory parts also. Because most of the time they are asking theory parts. What are the assumptions in Euler's theory? Like this, they will ask the simple and the straightforward question. So you should understand these all 6 topics. So first we will see assumption in Euler's theory. So actually his analysis was based on certain assumption in Euler's analysis. That means he was assuming something. Understand? According to assuming only he solved many problems. That's why it is known as assumption in Euler's theory. So actually in assumption in Euler's theory first says that column is initially straight. That means columns is straight. Understand? That is assumption. Actually it will be not totally straight, but they are assuming. Understand? So please keep in your mind. Many things it will be not in actual, but Euler's assuming everything to find the answer to the particular problem. That's why it is known as assumption. Understand? The first thing he says, columns is initially straight. Second thing, column is made of homogeneous material. Third thing, load is truly axial. And fourth thing is self weight of the column is neglected. Understand? And the fifth one is column fails only due to buckling. And the final thing he says the stress is within the elastic limit. Understand? फिर से एक बार आपको हम हिंदी में बताने जा रहे हैं कि जो यूलर्स था वो क्या assumption किया था और क्या थियरी दिया था एक कॉलम के बारे में. ये बहुत ही इंपॉर्टेंट है. यदि आप एग्जामिनेशन पॉइंट ऑफ व्यू देखें तो आपको थियरी पार्ट में भी ये क्वेश्चन पूछे जाते हैं और अभी हम लोग न्यूमेरिकल भी जो देखेंगे नेक्स्ट क्लास में उसमें भी इसका इस्तेमाल होता है. तो ये चीज जानना बहुत ही जरूरी है क्योंकि यदि आपको थियरी में भी पूछे तो उसमें भी इस्तेमाल कर सकते हैं, यदि आपको न्यूमेरिकल में पूछे उसमें भी आप इस्तेमाल कर सकते हैं। तो पहला चीज वो जो बोलते हैं, क्या बोलते हैं, कॉलम इज इनिशियली स्टेट, कॉलम शुरुआत में क्या होगा, स्टेट होगा। फिर कॉलम इज मेड अप ऑफ होमोजीनियस मटेरियल, कॉलम क्या होगा, होमोजीनियस मटेरियल से बनके बना हुआ रहेगा। फिर क्या बोलता है, लोड इज ट्रूली एक्सियल, लोड हमारा हमेशा एक्सियल रहेगा। और नेक्स्ट पॉइंट है कि सेल्फ वेट जो कॉलम करेगा उसको नेग्लेक्ट कर दिया जाएगा। जब भी न्यूमेरिकल प्रॉब्लम सॉल्व करेंगे तो जो कॉलम का सेल्फ वेट रहेगा, जो उसका जो अपना वजन रहेगा, उसको हम लोग हमेशा नेग्लेक्ट करेंगे। फिर क्या है, कॉलम्स हमेशा फेल करेगा किसके द्वारा, बकलिंग लोड के द्वारा ही, दूसरा अदर लोड के द्वारा नहीं कर सकता है। और लास्ट वो बोले थे कि हमेशा जो स्ट्रेस रहेगा वो इलास्टिक लिमिट के अंदर रहेगा। So these are the 6 points he says about the column. First one is column is initially state. Second one is column is made up of homogeneous material. And the third one is load is truly axial. And fourth one is self weight of the column is neglected. And the fifth one is column fails only due to buckling. And the final thing is the stress is within the elastic limit. Understand? Now we will see. He gave one formula. Understand? To find the buckling load. He gave one formula to find the buckling load. So that formula is known as Euler's buckling load formula or Euler's buckling load at failure formula. Understand? So actually if you will see the formula, see pi square E I minimum divided by LE square. As I told you, what is LE? Effective length. Understand? Effective length of the column. And effective length of the column is different for many conditions. Understand? If both end will be fixed, then another formula. If both end will be hinged, then another formula. So you have to remember those things. Understand? That's why I told you earlier. Some things you have to always keep in your mind during solving the numerical problem. So this point is also important. The formula for buckling load by Euler. So pi square E I minimum divided by LE square, where P is equal to Euler's buckling load at failure, E is equal to modulus of elasticity of column material, here E, I minimum is equal to moment of inertia of column section, this one I minimum, and LE is equal to effective length of column which depends on end condition. Understand? LE is equal to effective length. Actually, it will depends upon the end condition. If both end will be fixed, both end will be hinged, one end will be fixed, one hinged, one end will be fixed, another free. So according to the condition, we are applying the value of effective length. Sometimes effective length will become half of original length, sometimes it will become the double of original length. So it depends upon what, upon the end condition. Understand? So this formula you have to always keep in your mind to solve the numerical problem based on the buckling load. So P is equal to pi square E I minimum divided by LE square. Understand? Once again I will tell you, P is equal to Euler's buckling load at failure, E is equal to modulus of elasticity of column material, I minimum is equal to moment of inertia of column section, and LE is equal to effective length of the column which depends upon end condition. Now we will see what are the end condition of the column. Understand? This point is very important. Sometimes in your examination they will ask, write the end condition of the column. So in theory, if we will talk about theory parts, theory के अनुसार भी ये बहुत ही important है, क्योंकि बहुत बार एग्जाम में क्या बोलते हैं कि यूलर जो थ्योरी दिया था उसका एंड कंडीशन को एक्सप्लेन कीजिए। आपको कुछ नहीं करना है, आपको एक साइड एंड कंडीशन लिखना है। ये डायग्राम भी आप छोड़ सकते हैं, दिस डायग्राम इज नॉट इंपॉर्टेंट। टू मेक यू अंडरस्टैंड आई हैव kept here diagram, but diagram is not important. Only you have to know what is the end condition and what is the effective length. तो एग्जाम में भी आपको बहुत बार पूछते हैं कि एंड कंडीशन को एक्सप्लेन कीजिए कॉलम का। तो आपको क्या करना होगा, एक तरफ एंड कंडीशन लिखना होगा, दूसरे तरफ इफेक्टिव लेंथ आपको लिखना होगा। फिर आपको क्या करना होगा, फिर आपको देखिए जैसे कि इसका वैल्यू है, या पिछले क्लासेस में भी मैंने दिया था इसका वैल्यू, इफ बोथ ends आर hinged or hinged also known as pinned, both ends are hinged, then effective length will be equal to the length, original length, understand? If one end fixed and another end will be hinged, then effective length LE will be equal to L divided by root 2. If both ends will be fixed, then LE will be equal to half of original length L by 2, and if one end fixed and another end free, then LE will be equal to double of L. अंडरस्टैंड, समझ में आ गया? ये चार ही कंडीशन आपको हमेशा दिमाग में रखना है, ये आपको न्यूमेरिकल प्रॉब्लम सॉल्व करने में भी मदद करेंगे, और यदि थियरी बाय चांस पूछ दे तो थियरी में भी आपको क्या आएगा, ये आपका काम आएगा। समझ में आ गया? यदि दोनों एंड क्या है, हिंज्ड है, L इक्वल टू L, यदि एक फिक्स्ड है दूसरा हिंज्ड है तो L इक्वल टू L डिवाइडेड बाय रूट 2, यदि दोनों फिक्स्ड है आपका तो L इक्वल टू L बाई 2 हो जाएगा, और यदि एक फिक्स्ड है और दूसरा फ्री है तो L किसके बराबर हो जाएगा, 2L के बराबर हो जाएगा। ये इंपॉर्टेंट आप दिमाग में बैठा कर रखिए। नाउ वी विल सी यूलर्स जो होता है ना, जो कुछ और हमको दिया था फॉर्मूला, उसके लिए हम कैसे अप्लाई करेंगे। जैसे कि हम इफेक्टिव लेंथ को लेकर, समझ में आ गया, यूलर्स का तो एक ही फॉर्मूला है, यूलर्स का एक ही फॉर्मूला है, लेकिन यदि हम लोग इफेक्टिव लेंथ को ले लेते हैं, लेंथ के जगह पे, एक्चुअल लेंथ के जगह पे, इफ यू विल टेक इफेक्टिव लेंथ इंस्टेड ऑफ एक्चुअल लेंथ, देन हाउ आवर फॉर्मूला विल बिकम। This is very important, my dear students. Then one more thing I will say you side by side. If you don't want to remember these things, then okay, no problem. But you have to remember the original formula. Understand? Original formula for buckling load by Euler's. If you will know the original formula for buckling load by Euler's, and if you will remember the end condition of each and every support, then no need to remember this formula. But if you fail to remember those things, then you must have to remember this formula. So we will see this formula also. This is not mandatory. If we focus on those things, this thing is nothing. So for both ends are hinged, then PE is equal to pi square E I minimum divided by LE square is equal to pi square E I minimum divided by L square. Why? Because if both ends are hinged, then LE will become L. Understand? That's why. Understand, my dear friends? If both ends will be hinged, then our effective length will become actual length. Now we are going to see the second condition. What is second condition? If one end is fixed and another end is hinged, then what will happen? As I told you, if one end will be fixed and another end will be hinged, then what will happen? Then LE will become L divided by root 2. Understand? LE will become L divided by root 2. That's why this is the formula. If both ends will be fixed, then L will become, actual length will become L by 2, effective length, in case of effective length. So actual length will become L by 2. This is L by 2. That's why I told you, if you will remember those formula, then no need to remember this formula. You can just remember the main formula of Euler's for buckling load and the end condition of each and every load, each and every support. Understand? Then finally, if you will see one end is fixed and another end is free, then we will apply 2L. Why? Effective length LE will become 2L. Understand? So these are the formulas which you have to keep in your mind to solve numerical problem. You will see numerical problem also, that time also I will explain you in a better manner. Okay? No problem. Now we will see what are the limitation of Euler's formula. If you will see buckling load by Euler's formula is given by this formula. Understand? These are the derivation. So sometimes they may ask in your examination point of view. That's why I have given here. So already you know the buckling formula for Euler's. Understand? So I minimum will become AK square. I minimum will become AK square, and the same thing. Then finally this will come down. If you will take a that side, if you want to see, then it will become, finally we will get one equation, sigma c is equal to pi square E divided by LE by K square. Understand? This is also important. So because sigma c is equal to PE divided by A, na, that's why it will become like this. And already we know the cylindrance ratio, LE by K. Understand? We know cylindrance ratio also. Suppose that for mild steel E is equal to 210 gigapascal and sigma c is less than 320 Newton per millimeter square. If we put in that equation, then finally we will get LE divided by K, which is greater than or equal to 80.48. So if you will see, Euler's formula is valid for cylindrous ratio more than 80.48 for mild steel column, so that the stress does not exceed permissible value. So Euler's formula is valid only for long columns only. Understand? Euler formula is valid for long columns only. That is the point I want to convey you. Actually, if you will see, we can apply in short column also, but that will be not that much applicable or useful or effective. That's why one thing, actually, if you will see the limitation of Euler's, then it is only valid for the long column, not for short column. Understand? If you will talk about the long column, the Euler formula is valid for cylindrance ratio is more than 80.48 for mild steel column. Understand? That's right. Okay. Now finally we are going to see Ranki's formula for buckling load. This one is very important. Understand? Most of the students, they used to only focus on Euler's formula and they used to forget these things. But you have to always keep in your mind. In 1 marks question, they will always ask what is Ranki's formula for buckling load. So formula is PR is equal to sigma CA divided by 1 plus alpha into LE by K whole square, where PR is equal to buckling or crippling or critical load by Ranki's formula. Sigma C is equal to permissible compressive stress in column. LE already you know, LE is equal to effective length. A is equal to area of cross sectional of member. K is equal to radius of gyration, and alpha is equal to Ranki's constant. So this is the formula. This is the formula for Ranki's buckling load. Understand? So you have to keep these things also in your mind. Once again I will repeat it. PR is equal to sigma C by A. No, PR is equal to sigma C into A divided by 1 plus alpha LE by K whole square. Okay. If we will see what are the important questions throughout our unit 1, especially the lecture which we have seen in past 1 week, then first one is define columns and start with example. They will ask in a university question. Then they will ask define cylindrance ratio, define equivalent length of column, also state the different in condition and their corresponding effective length. See, these are the questions I have selected from the questions bank. And so mostly they will repeat these types of question again and again. Understand? That's why you have to keep these questions always in your mind. If you are able to solve these types of question, or if you are able to answer these types of question, then no one will stop you to get good marks. So what is first in your examination, they may ask define columns and start with example, define cylindrance ratio, define equivalent length of the column, and also they will ask the same condition, end condition and the effective length. Then they will ask state Euler's formula and meaning of each term involved. As I told you, you have to write the Euler formula, then you have to explain each term, what is the E stands for, what is sigma stand for, everything you have to explain. Then write down the various assumptions in Euler's formula. As I told you, they may ask in the theory parts also. Then write a short notes on limitation of Euler formula. You have to write the short notes on limitation of Euler formula also. What are the limitation on Euler formula? As I told you, Euler formula is not applicable for short column. It is only applicable for long column. So you have to keep in your mind. Then finally, state Ranki's formula and the meaning of each term involved. Understand? See, this is very important, my dear students. See, these two questions are directly from the formula. You have to write the Euler formula for buckling load and each term you have to explain. Here you have to write the Ranki's formula and you have to explain each term. Then one more thing I have told you, assumption in Euler formula, as I told you, 6 points. Understand? So question will come directly, but you should know how to write. If you will understand clearly, then no one will stop you to get good marks. So I hope you all must have got a clear concept about the topics which we have covered throughout this lecture. First one is assumption in Euler formula, or Euler's theory, then Euler's formula for buckling load, limitation of Euler's formula, then finally we have seen Ranki's formula for buckling load. So if you want to gather more knowledge about the particular topic, then you can refer these two books. First book is Strength of Material by Dr. R.K. Bansal, Dhanpat Rai and Sons publication, and the second book is Mechanics of Solid by R.S. Kurmi, Strength publication. Thank you. I hope you all must have got a clear concept about the particular topic in lecture 17 named Euler's Theory. Once again, I will tell you, my name is Sudhir Kumar, a lecturer in Mechanical Engineering from JIMS Polytechnic College, Aurangabad, Bihar. Thank you.